I always wanted to be a scientist as long as I can remember, and I always wanted to work on cancer research from quite a young age. I first visited the Institute in 1991 when I was a high school student, and I was very inspired and came back to do a vacation scholarship, which was a summer research program offered by QIMR Berghofer when I was an undergraduate student. And then I started working here in 1997. I now try to offer those kind of opportunities to young people because I know what a difference it made in my life. And I've had a number of students come through my lab now to do training, and they've stayed on and done their PhDs, or they've become research assistants in my lab. So I've been researching colorectal cancer for around 3 decades. The work I've been involved with, which has been most impactful, is what I would refer to as understanding the serrated pathway. And what that means is there's different kinds of polyps that grow in the bowel, and there's a certain type of polyp called a serrated polyp. And years ago, when I started out in the field, these polyps weren't even recognised as having potential to become cancer, and often weren't even removed at colonoscopy. And we now, over the last few decades of work that I've been a part of, we now realise they're about 25% of colorectal cancers grow from this polyp type. Then there's large efforts now made to remove these polyps. It's extremely gratifying to think that something I've contributed to has actually changed clinical practice and is making a difference to patients. So I'm very proud of that. Bowel cancer is one of the most common cancers and is the second leading cause of cancer-related death in Australia. There's over 5,000 Australians each year will lose their life due to bowel cancer. So that's a terrible statistic that we're trying to improve. The work I'm doing now, I'm growing the patient-derived tissue in the laboratory to try to predict which drug will work best. We collect tissue at the time of surgery. We take the cancer tissue back to the lab, grow the tissue in the lab, and then any drug that the patient might be able to be offered, we put on the cancer and see what actually kills it. And then we hope to, in the future, feed that information back to the oncologist so that patients who do have advanced cancer are offered the most appropriate treatment up front. This is really important because it will reduce the use of drugs that could be quite toxic in patients when they're unlikely to respond. And also, particularly in the advanced setting, there may not be a lot of time to try different drugs. So if you can prioritise the drug most likely to work first, then that's of great benefit to the patient. I think that as a community, we can all be very proud of QIMR Berghofer. The Institute has been here for 80 years, as we know, and has really set the standard for internationally renowned research. There's been so many discoveries that have come out of the Institute, and I certainly am so proud to have spent most of my career here.